Dear students, in the last session, I had explained Kirchhoff's laws. But in this session, I will explain the mesh analysis method. This is the first method is used for solving an electrical network. The definition of the mesh is it is a loop that contains no other loop within it. Mesh analysis method uses Kirchhoff's voltage law to determine the unknown currents in the given network. Mesh analysis is also called as mesh current method or loop analysis method. To an analysis of DC circuit by mesh analysis method. First, identify the independent meshes or loop in the given network. Step 2. Assign a circulating current to each mesh. Step 3. Write the KVL equation for each mesh. Step 4. Solve the KVL equations either by elimination method or by Cramer's rule to find the unknown mesh currents. Using them, we can find the different branch currents. Analysis of DC circuit by mesh analysis method. The given network, let I1 and I2 are the currents in the loop 1 and 2 and loop 2 respectively. Apply KVL to the loop 1. I am starting from this point. Say I1 into R1 plus I1 plus I2, that means the I2 current flowing in the mesh, in the loop 2, that means the I2 is along with I1, say, so I1 plus I2 and plus, that's equals to I1 plus I2 into R2, that's equals to E1. That means the rise in potential in source, that means negative to positive, we must take positive and plus E1. I1 into R1 plus R2 plus I2 into R2, that's equals to E1. Say the equation 1. Apply KVL to the loop 2. I am starting from this point. I2 into R3, I2 into R3, I2 into R3, I1 plus I2, I1 plus I2, that means the current I1 is flowing in the mesh, loop 1 along with the direction I2. So I1 plus I2 into R2, and next from negative to positive in the source E2. So we must take plus E2 in this side, that means that's equals to E2. I2 into R2 plus R3 plus I1 into R2, that's equals to E2. Say that equation 2. Solve the KVL equations. Solve the KVL equations means these two equations, equation 1 and equation 2, either by elimination method or Cramer's rule to find the unknown mesh currents. According to Cramer's rule, the equation 1 and the equation 2 can be written in the matrix form as, in this we have the left hand side of the system with the coefficient matrix, that means I1, the coefficient of I1 and the coefficient of I2, and the right hand side with the answer values, that means E1 and E2. Next, let delta be the determinant of the coefficient matrix of the above system, and let delta I1 be the determinant of the matrix formed by replacing the first column values of the coefficient matrix with the answer column values. That means the first column values means this one, the first column values is replaced, this is the first column value is replaced by the answer column values E1 and E2. And next, let delta I2 be the determinant of the matrix formed by replacing the second column values of the coefficient matrix with the answer column values. That means determinant of the matrix formed by the replacing the second column. That means this is the second column values is replaced by with the answer column values. Answer column values means E1 and E2. The mesh currents I1 and I2 are given by I1 equals to delta I1 divided by delta, I2 equals to delta I2 divided by delta. Next, problems on mesh analysis method using KVL. In the following network, calculate the currents and the potential difference across 2 ohm using mesh analysis method. Consider the network, given network. Let I1 and I2 are the currents in the loop 1 and loop 2 respectively. Next, apply KVL to the loop 1. I am starting from this point. Say I1 into R1 plus I1 plus I2 into R2, that's equals to E1. I1 into R1, R1 equals to 1 ohm plus I1 plus I2, R2 equals to 3 ohm, R1 equals to 1 ohm, R2 equals to 3 ohm, that's equals to E1. That means the source is E2. Next, 4I1 plus 3I2, that's equals to 2, say the equation 1. Next, apply KVL to the loop 2. I am starting from this point. I2 into R3 plus I1 plus I2 into R2, that's equals to E2. Next, I2 into R3, that means 2 ohm plus I1 plus I2 into R2, that means 3 ohm, that's equals to source 4 volts, that's equals to 4. Next, 3I1 plus 5I2, that's equals to 4. Say the equation 2. The equation 1 and the equation 2 can be written in the matrix form as, in this we have the left hand side of the system with the coefficient matrix, that means the coefficient of I1 and the coefficient of I2, and the right hand side with the answer values. Answer values means 2 and 4. Let delta be the determinant of the coefficient matrix of the above system. The determinant of the given matrix is 4 into 5, 4 into 5, 20, 4 5s are 20, minus 3 into 3, 9, 20 minus 9, that's equals to 11. Let delta I1 be the determinant of the matrix formed by replacing the first column values. First column values means 4, 3 of the coefficient matrix with the answer column values. That means 4, 3 is replaced by the 2 and 4, 3 is replaced by 2 and 4. Answer column values. The determinant of the given matrix is 5 into 2, 10 minus 4 3 is 12. 10 minus 12, that's equals to minus 2 amp. Next, delta I2 be the determinant of the matrix formed by the replacing the second column values. Second column value means 3 and 5 of the coefficient matrix with the answer column values. Answer column values means 2 and 4. The determinant of the given matrix is 4 4s are 16 minus 3 2s are 6. 16 minus 6, that's equals to 10 amp. Next, the mesh currents I1 and I2 are given by I1 equals to delta I1 divided by delta. You know delta I1 equals to minus 2 amps. That means minus 2 divided by delta. Delta equals to 11. Minus 2 divided by 11, that's equals to minus 0.18 amp. Next, I2 equals to delta I2 divided by delta. You know the delta I2 equals to 10 amp. 10 divided by delta equals to 11. 10 divided by 11 equals to 0.9 amp. Next, the potential difference across 2 ohm is equals I2 into 2. You know I2 equals to 0.9 amp. 0.9 into 2, that's equals to 1.8 volt. The potential difference across the 2 ohm is 1.8 volt. This method is used for solving by electrical network. By solving any electrical network. Thank you.